Okay, engineering students, let us proceed from where we left last time. We're looking at this structure. As you can see, it's an illustration of the bond line structure, to which when you see an end like this one, it's tell you there is a CH3, there is a carbon with 3 hydrogens. When you see this this end here, it's telling you that there is a carbon with 2 hydrogens. This is a carbon with 1 hydrogen, this is a carbon with 2 hydrogens, carbon with 2 hydrogens, carbon with 2 hydrogens, carbon with 2 hydrogens, carbon with 2 hydrogens. Okay? So this group which I'm showing as blue, or perhaps let me just try to show it in red, yeah? That's what I'm calling a substituent. And that substituent has got how many carbons? It has 1 carbon atom. Just to show you this structure, I hope you can see this one very well. This is similar to this structure here. Okay, so let us see. Okay, the parent chain is taken as the longest carbon chain. Can you see the way? Okay, let me just put it correctly. All right, can you see the way it's zigzag, or perhaps, okay, let me put it in this form so that it will be the same. Whether you put it up or down, it's just the same structure. Can you see carbon number 1, number 2? Okay, let me put it like this so that you can see what carbon number 1, number 2, number 3, number 4, number 5, number 6, number 7, and number 8. Okay, so in this case I've just put the substituent with just a different color so that you can be able to see here. It just means that this is where this way I had a hydrogen. Okay, let me just put it back so that you can see exactly. Just a minute. Okay. All right. So this is what I had. Okay, let me return it back to how it was. Okay. So this is how the structure was. Let me put it correctly. Okay. So the zigzag manner. Can you see? The carbon at the end has got how many hydrogens? I'm putting it here, 3. The next to it has got 2 hydrogens. The next to it has 2 hydrogens, 2 hydrogens, 2 hydrogens, 2 hydrogens, 2 hydrogens. The last one, which you can see here as I put it to you, it has 3. So this is what I'm showing us as 1, 2. Okay, let me put it correctly. 1. Okay, is it clear very well? Perhaps I can use this pen to show. Okay, 1, 2, 3, 4, 5, 6, 7, and 8. So this is what I had as the one which I'm showing as my zigzag line. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, and 8. I'm repeating this point because it is laying a foundation to these bond line structures, because we are going to be focusing on this bond line, this zigzag, as an illustration of this carbon. So you have to relate this zigzag pattern to this structure which I have here, because it is too cumbersome to be drawing this carbon with the hydrogen, carbon with the hydrogens. So if you're going to know this zigzag man and what it represents, then you're going to be okay. Now, coming to our structure here, I say that I just counted up to carbon number 1, 2, and 3, and then like this is carbon number 3, yeah? So in the carbon number 3, what I have done is to remove one of the hydrogens, yeah? Maybe I've removed that. Okay, let me point it here. Okay, so this is what I had. All right, are you okay? So I have removed one of the, okay, let me remove the one which is closest to you. You can see there, I've removed that hydrogen, and then I've added a group there called a methyl group. It has one carbon atom. Yeah, it has one carbon atom. So the thing is this, the substituent which I've got here, what can you see about it? It has one carbon less than the hydrocarbon, which has an equivalent number of carbon atoms. So if it was a hydrocarbon with one carbon atom, it would have been called methane. But because it is one carbon less, it's called a methyl. This is a substituent. It's not complete. It can be joined to the parent chain. Yeah, can you see? Just like you can say it's like, this is like a tree, and then the substituent is a branch. Yeah, can you see? Here you've got a branch with one carbon atom. Just as you can have another branch with 2 carbon atoms, another branch with 3 carbon atoms, which will be called a 3 carbon atoms, which will be called a propyl. 4 carbon atoms, it will be called a butyl. So remember, as I mentioned, in this course for engineering, we are not going to be going beyond 4 carbon atoms for substituents. So we'll just focus on up to 4 carbon atoms. 1 carbon atom, methyl. 2 carbon atoms, ethyl. 3 carbon atoms, propyl. 4 carbon atoms, butyl. Is that okay? All right. So, okay. Okay. So this is the substituent containing one carbon atom. I think what I'm just going to do, I'm saying the phone was set to be receiving messages, and that may interfere with the sound. So I'm just going to stop a bit and then turn off the Wi-Fi, so that I think there will be no sound of the receiving of the WhatsApp messages. Yeah, I'm just going to stop so that I'll be able to turn off the Wi-Fi, and then we'll proceed from there. Sorry for that small interruption. Are you okay? Right. So 8 carbon atoms. 1, 2, 3. At carbon number 3, there's the substitute which I put with the red ball. The black balls are showing the carbon atoms of the main chain. Is that okay? Okay. So in a short while, I'm going to stop the video, and then we're going to proceed from there. Okay.